stage and hope you're ready for more innovation topics. Don't hesitate to raise your questions in the chat box on our website during the session and then join the networkings after each session. For our next topic, we have the whole team of presenters, Ivan, Hira, Asad, and Mujtaba. Hello, team. How are you? You have a quite trending topic on blockchain today, so please introduce yourself and proceed with your presentation. The stage is yours.
Okay, thank you. We are happy to start. My name is Ivan Gudymenko, and I'm a security and blockchain architect at the Systems Multimedia Solutions in Dresden. Folks.
So my name is Mujtaba. I'm a working student in the Systems MMS. Under me, Hira.
Yeah, hello guys, I'm Hira, and I'm also a working student at the Blockchain Solutions Center in T-Systems MMS.
Hi guys, this is Asad here. I'm also a work student in the Blockchain Solutions Center's T-Systems MMS Dresden.
Thank you for your introduction. Maybe some of our audience ask themselves why we are in such a large round here. The main reason for that is that we have had an interesting project with BMW in Germany, and after our blockchain topics, we also published a paper, a scientific paper on the topic you are currently seeing on your screens. And usually there are more people writing a scientific paper, and therefore it was important that all of these people or the contributors also present their parts today and can share their insights with you. So maybe let me start with the introduction. Basically, our presentation today is about the privacy-preserving blockchain-based systems, especially for the use case of car sharing systems. And an example of car sharing, we took the BMW mobility network. So let me just start. Basically, we have from the presentation structure as follows. We will make a short introduction to you, describe a general system setup, and then present two solutions we suggest for the system, and then discuss the results. Basically, the mobility services in Germany and also in Europe are gaining popularity, and more and more systems and car providers try to suggest the new services to the population. And one of them is, for example, Share Now, which is gaining popularity not only in Munich, but also elsewhere in Germany. And mainly one of the reasons for that is that in large cities, it's often very difficult to park the cars or any mobility device that people have, such as scooters and such stuff. And therefore, it is sometimes very beneficial to rent a car or a mobility device while being in a city. There are also further reasons for that, but the trend is clear. The mobility services are gaining popularity. Well, usually, in order to use these services, a special registration is used and is required, especially if you are using not only some kind of electric scooter, but a normal car. For that, you usually need to present a valid driving license ID, a national ID. And in order to book some added value services on top of that, such as, for example, some loyalty programs, golden member, for example, of some BMW network and such stuff, then you usually need also to share more information pieces that are usually needed. And this is often due to the all or nothing paradigm of information disclosure being described basically in an official document. Well, what we wanted to achieve in our project where we cooperated with BMW on was to provide a proof of concept for a blockchain-based ecosystem where people can rent and consume their mobility services such as car rentals, and also consume the services which are created around this ecosystem. For example, special mobility and loyalty programs, such as some for special customers, maybe some further value-added services, and therefore, so on and so forth. An important focal point of our research was that we wanted to provide the flexibility of a sharing ecosystem, incorporating more than one from a mobility provider, such as BMW, maybe further companies such as maybe Volkswagen and Audi, etc. And at the same time, we wanted to ensure their data minimization in our system and to provide for verifiable credentials in the system, which, however, do not disclose more information than absolutely necessary to get the service. So I think that it is clear that especially in Germany, as also in the whole Europe, the compliance regulations are of paramount importance, especially the privacy ones. There is a privacy directive which manifests how the privacy of the individual should be adhered to in the IT systems. And as we all know, the blockchain-based systems usually have a special properties, such as that the data cannot be deleted per se, since it's a blockchain, and some other properties that sometimes are orthogonal to the privacy regulation requirements. Therefore, in our project, we try to provide for the countermeasures for that. To give you an example, usually if a driving license is presented, such as here, as you can see, usually it adheres to the all or nothing paradigm, basically that all the attributes that are based in the driving license, such as their eye color, their birth date, and so on and so forth, are disclosed in full entirety. Very often for some value-added services, it is not necessary, whereas it is important just to know particular fields of this, such as the age or even the age range, older than 18, or the driving license experience, more than 2 years, more than 5 years, and so on and so forth, and of course the driving license class. Well, usually in order to deal with such kind of data pieces, the systems, the data controllers have to be able to comply to legal obligations. It's often a high effort to manually or automatically process this data and to ensure data compliance. And to make the thing worse, usually some special service, some value-added services, they really do not need this type of information. They only need a specific parts of this information, such as I mentioned before. So what we can do is basically to digitalize such attributes as driving license class A, B, C, or D, or such stuff, on the birth date or experience of a driving experience, and create a so-called selective disclosure of such credentials, and to be able to prove to in the system scenario that a certain attributes are possessed. And this is the picture to the right. You see that it can be presented on the specific statements over the attributes that the person has. Please compare to the left, you can see the exact birth date and so on and so forth. And on the right, you see that the person is just over 21, that the document is as such valid, and the car class, which is stated there, in this case it's a C or maybe also B, is also the one that is needed to provide the service, such as to rent a car. What we did to implement this was the so-called zero knowledge proofs, and we will now provide you with the intuition of what it is. In order not to get into too deep into technical details, what we can state is that the zero knowledge proof is basically the proof of some particular secret that the person possesses without revealing this secret information. To give you a very simple example is, you can see the person Catherine to the left that which acts as a verifier of some special secret, and the hiker to the right knows some secret but doesn't want to disclose it. So we have prepared here a short animation for you, just to give you an idea, a hint how it is usually, how it can be done, such based on the example of a door lock code. So what you can see here is more or less a special system where Catherine to the left asks Heiko to the right to pass the door, which he knows is closed. And the code for this door lock is some kind of a digit code that Heiko knows, but he does not want to disclose this code to her. So what she does, she just asks him to go many times either over the route to get out of this cave, which is called the Alibaba cave, to get out either over the route A or the route B, depending on how she challenges him. So if she challenges him with enough number of times, then she can be sure that only knowing the code, which she doesn't see, which he enters, the person hiker can exit this particular cave. And by that, hiker hasn't disclosed the secret code to Catherine, but she is persuaded that the only way that he could have left the cave is by knowing the code. And this is basically the intuition behind the so-called zero-knowledge proofs that we were using in our system. Maybe to give you an example how we concretely use this, we use the driving license attributes, such as the driving license class A, B, C, or the combination of this, and the driving experience, and so on and so forth. All of these attributes can be digitalized and then presented and they can be proved in a zero-knowledge fashion, as we just saw before, without disclosing their direct value, so that the verifier, in this case, some car renting company or other instance cooperating over the blockchain-based system, can be persuaded that their claim that the person holds is true, without seeing the exact value of this secret information, which is in this case the privacy-preserving information, privacy-critical information. Therefore, we could provide for a privacy-preserving driving license check on blockchain, here to the right, privacy now, as opposed to the usual check that, for example, the police does or the companies are doing now, where the whole driving license is presented. And as already stated, we have presented this on the annual conference of distributed applications in Oxford, where our paper has been accepted to the proceedings. And the link to the article you can ask later. I provide it to you, of course. I will end my introduction with the sort system setup that we have devised. So basically, in our system setup, there was a transport authority, basically the instance that issues the driving license. We had an end-user application, be it an end-user terminal or particularly a smartphone of a user who wants to consume the services such as car sharing services and maybe other further valued services. And we have an example of the car rental pool. This is the verifier instance here with the car to the right. And the last but not least, we have a membership status provider, which is this example of the value-added services where each participant can hold a specific status of BMW, golden, silver, and platinum, which can lead to some kind of specific properties and discounts, maybe by car rental providers. Important is that all of these parties are connected over the blockchain layer, and by this we have a independent blockchain-based ecosystem where all these parties can basically communicate. So in a nutshell, usually the user gets the credential over the driving license from the transport authority, and there is perfectly fine if the privacy-preserving attributes are disclosed. It mimics the usual process of obtaining a driver license, and then having all the credentials digitized in a smartphone. So basically, all of these credentials, which you can see here in a normal driving license, the user can selectively disclose in zero knowledge these credentials to the rental car pool provider and also to the further services such as BMW Group membership. The same happens when the user obtains further credentials from the BMW Group or any other member of the network in order to achieve for some services. An important part here is that all of the credentials are combined on the end user device, and only this end user device can afterwards link the transactions on the blockchain to this particular user. So the user is in control of his or her identity and credentials. This has been the yeah, this has been the introduction. Now I would like to give guys the presentation to you for the concrete technology Indy that we use to implement this use case.
Hi everyone. So the first technology that we used for this use case was Hyperledger Indy. Hyperledger Indy is basically one of the projects under the Hyperledger umbrella, and this Hyperledger Indy is a framework that was specifically made for anonymous credentials with zero knowledge functionality and selective disclosure. So what the features of Hyperledger Indy are, just to give a background of what Hyperledger Indy is. Basically, this framework supports issuance, revocation, and verification of digital identities. And to as a root of trust, the information of these credentials are rooted on ledger technologies. It could be any kind of ledger. Hyperledger Indy uses Plenum blockchain framework, but there could be other underlying ledger technologies that could be used as well. The very interesting part about Hyperledger Indy was that the identities on this framework were via decentralized identifiers, also known as DIDs. So what's the interesting thing about DIDs is that normally when you think about public blockchains like Ethereum, there is one address associated with each identity. And if a person with one address does enough transactions on the network, there is always the possibility that the address could be correlated to the actual identity of the person. So this possibility is always there when you talk about public blockchains that use a single identifier for one person, for one wallet. But what Hyperledger Indy does is that it basically creates one identifier for every interaction, for every credential that a user creates. So, for example, if I am a user and I ask for a driver's license, my wallet would have a decentralized identifier for the wallet credential. Later on, when I go to any other credential like a transcript or a passport, it would have a different decentralized identifiers. Mathematically, these different decentralized identifiers all come from the same master secret or the root. So so that's the surety that they belong to the same person. But if you look on the blockchain, you can never correlate them to a single person. So this is one of the strong points of why Hyperledger Indy framework is useful for anonymous credentials. Moreover, Hyperledger Indy follows hierarchy of trust. By hierarchy of trust, I mean that not everyone can come on the network and can start generating credentials for different users. You should have some sort of rules, you should have some sort of authority that you're able to generate credentials for different users. And lastly, Hyperledger Indy supports zero knowledge proofs, which were earlier explained by Ivan, and they also support selective disclosure. Ivan, can you move on to the next slide? Yeah, so talking about roles in Hyperledger Indy basically has 4 different kinds of roles, and each of these roles has different authorities over what they can do in the network. Not everybody can do everything. For example, a simple user can just interact with other entities, but they cannot, they can only ask for credentials, they can only request for credentials, but they cannot generate credentials for anyone else. A trust anchor is an authority that can basically create credentials. They can publish the credential schemas. They can create credentials for the users. A steward is basically every organization that is at the part of the consortium on the Hyperledger Indy framework has one steward. A steward can add the node that is responsible for adding the transactions to the ledger, and the steward can add trust anchors, which would further then generate credentials for the users. The trustee is the highest authority in the consortium of Hyperledger Indy. A trustee is like the board of directors in any organization. A trustee can add or remove other trustees. They can add stewards. They can add trust anchors. They are basically you could say the boss of the network. Ivan, can you please move to the next slide? So in our use case, what we did was that we basically had a customer with a client wallet. The client wallet would then request for a membership credential from the BMW Trust Anchor. And then the client wallet would request for the license credential from the GmbH Trust Anchor. GmbH is basically the German department that issues the driving licenses. So once the client has the membership credential as well as the license credential, now the client wallet can actually create a composite proof consisting of some selective information from these two credentials, and the client can then submit this proof to the card, which is in this case is acting as the verifier. The verifier, once it gets the proof, it fetches information from the BMW Trust Anchor as well as the GmbH Trust Anchor to actually be sure that the proof that the client wallet has submitted is valid and it's not revoked and it's not forged in any way. And if the proof is verified, the client wallet would get access to the mobility pool. And if the proof is not verified, there's some kind of problem with the proof, then the client wallet would not get access to the mobility. Next slide, please. Now we have to play the video for the demo of Hyperledger Indy.
Yes, the question is if the colleagues would do it for us. I presume not, so I will do it for you folks.
Okay.
Видео нет? Видео есть?
Give me a second. Now it should be working. Just let me get back, and you please tell me when I should.
Yeah, can you just pause the video? Okay. So since there is no voice over here, we cannot hear the voice on this video. So I will just explain what these 4 screens are representing in this case. So in this case, there are 4 different clients. These like 4 screens are basically 4 clients representing the various entities in the network that we explained earlier. The top left screen basically represents the trust anchor for the BMW network, and left bottom left represents the client for the trust anchor of the government network that will be responsible for issuing the credentials to the user. And then at the right side we have again 2 clients. The top right client basically represents the user which will be requesting the credentials from the KBA and BMW Group network. So basically, let's talk about these 3 first. The client would first go to the BMW network and would request them the membership credential. So the BMW trust anchor would recognize the user. I mean, obviously, the user has a login and has a history with them. So they will provide him a digital credential that the user would save in this wallet. You can see at the top, the user provides this, like the credential contains the user's first name, second name, and then the number of years of experience. Now, actually, I'm talking about the one at the top. Then they provide the membership level, that is gold in this case. So the user saves this information in its wallet, and then the user goes to the government network, and the government network also provides the credentials to the user. For example, the number of years of experience. For example, user has 8 years of experience. He has license class C, and all this information gets stored in the user wallet. And then once user has this information, he goes to the car, and the car basically publishes the information that is required to open this particular car for a particular user. So in the verifier pool, the car could be of various categories. The car could be gold class, platinum class. So the car basically publishes that I require these credentials for a user to access me. Then the user basically creates a proof based on those credentials for the car, and the user creates a proof in a zero knowledge way and in a selective disclosure way, so that it only provides the information that is needed in this case, not all the information. The car, when receives the proof, basically verifies the proof cryptographically. The proof may contain some information like using first name and second name, and then there can be some membership level predicates. For example, membership level should be verified, but the user does not reveal what membership level it is exactly. And then the number of years of driving experience and all these predicates, they are verified in a zero knowledge way. So if all this information is cryptographically verified via blockchain, the car gets opened for the customer. So that is how this demo is like working on console application for now.
Okay, thank you very much. It's a bit was a bit fast one. Thank you very much for making it. Let me check. Yeah, we are don't have a lot of time, but I will just ask our organizer to give us 5 minutes more because we started much later. And the second technology, which may be known to the audience, is the so-called ZoKrates, named after the Socrates, which used to say that he knows nothing, which some kind provides for an intuition for what zero knowledge proof actually is. And this is a very popular technology on Ethereum. And I would ask Asad, maybe in a short condensed fashion, but to provide the overview of this technology and of its implementation for our paper as well, please.
Hi guys. So we developed the use case using two technology. One was described by Mujtaba and Hira, and second one is this. So ZoKrates is basically a toolbox for ZK snarks on Ethereum. For most of you who don't know what ZK snarks are, so they are a novel form of cryptography which are used to generate zero knowledge proofs. As Ivan explained earlier. So what ZoKrates does is that it enables verifiable computation, which in essence is that any sort of computation or proof whose authenticity can be verified and source can be verified. In ZoKrates, two aspects. So the generation of the zero knowledge proofs is off the chain, which means that it's not done on the blockchain, but it's the proofs are generated inside the via the program of which is compiled in ZoKrates, and they are generated on the device. And however, the proof verification is done on chain via the verification smart contracts that are obviously published on the Ethereum blockchain. These verification smart contracts are pre-written and generated via ZoKrates. And basically they involve, they contain the proving schemes and a lot of cryptography which is used to verify the proofs which are generated off the chain. Okay, so Ivan, can we move to the next slide? Okay, so this is basically the architectural diagram for our implementation. So the implementation starts with the trusted setup, which is done via the secure entity. So we call it the secure entity inside our implementation, but originally it's done inside the ZoKrates engine. And the first phase is the trusted setup, which generates the prover and verification key. And then based on that verification key, the ZoKrates generates a verifier smart contract, which has the verification key embedded inside it. And at the same time or simultaneously, or the third step, which is the issuer registration, it can be done parallelly with all of this or after or before this step. And then the issuers, which are the BMW and KBA, they have to register themselves on the blockchain inside the smart contract, which we call the attributes contract. And after that, the issuers grant the credentials for the car sharing service to the user. And once the user has these credentials, so they use the credentials, including the ZoKrates engine. So they use their credentials and the ZoKrates engine to generate a zero knowledge proof using the prover key, which was granted to the user in the first phase, which is the trusted setup phase. And since now the user has a zero knowledge proof on their device, so they can present that zero knowledge proof, including their credentials. By the way, I just missed one thing, sorry. In the fifth step, as soon as the issuers issue the credentials for the service to the user, they also publish the signed hashes of these credentials to the blockchain inside the attributes contract, whose sole purpose is to register the issuers and store the credentials of the users. So in the end, as the user has presented their knowledge, zero knowledge proofs and their credentials to the blockchain, so now the car sharing service can verify these the zero knowledge proof using the verifier contract, which is also published on the Ethereum blockchain, and they can also verify the credentials that the user has submitted the correct credentials, which were issued by the respective issuer. And in this way, the car sharing service, after verifying all the stuff, can then offer their service to the user. So having said that, the ZoKrates framework was specifically designed for public blockchain, specifically for Ethereum blockchain. Yeah, that's that. So Ivan, can we move to the next slide? So we have to play the demo.
No, the same game again. Give me a second, please.
Okay.
Can you see it now? Yes, you can. Good.
Yeah.
So,
do we have the voice, or should I explain?
We have your voice for this, your live voice.
Okay. 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 So we use the ZoKrates engine to initiate a trusted setup by compiling the pre-image function, which is having the selective attributes as the parameters. And as a result, it will generate the prover and verification key, including the verifier smart contract. Then we would select the credentials that we want to prove. And then in the request characteristics phase, it involves the issuer to verify the credentials in the database and issue the signed credentials to the user for the car sharing service and publish signed credentials onto the blockchain. And then at the end, the user uses ZoKrates to generate the zero knowledge proof using the prover key and presents the proof on the blockchain. And the verifier then verifies the zero knowledge proof using the smart contract. Yeah, so this is the proof verification phase, where the car sharing service can verify it using the smart contract.
Okay, thank you. That was a very short demo we did, yeah, for the ZoKrates part with a fancy front end. Yeah, I think the evaluation. Maybe I can simply, since we don't have enough time to go into details, I will simply want to once again to elaborate, to sum up that we have used two technologies to build up the case. This is the one that you have just heard, the ZoKrates one, specifically made for the Ethereum-based blockchains, and the former one was based on the so-called Indy technology, which relies on some different IDMX cryptographic primitives, which may be interesting for the colleagues from St. Petersburg because they were also working on distributed identities such as sovereign. There are some different properties of each of the approach, which you are very welcome to read in our paper for more detail if you wish, or simply talk to us on that and we can help you. We have measured the performance as well, and in general, without going into much details, the Indy performance of the Indy, the first approach with the selected credentials disclosure is much better due to the inherent properties of how the proofs are generated and checked in Indy versus ZoKrates. But as you can see, the values are for the proof of concept are still manageable, with of course Indy being much better in this case. The details you can find in our paper as well. And to conclude our presentation, as I have just mentioned, the solutions for the generic approaches based on Indy seem to be more flexible in terms of the credential issuance and selective disclosure, and more efficient. And we envision that for a number of cases, Indy would be the first choice, especially in the area of distributed identities and such sovereign-based network gaining importance. in the digital world, not only in the blockchain one. However, if the compatibility with the existing networks, such as Ethereum-based networks, is required, then ZoKrates can be used to provide for the functionality in this direction as well. And I think with this, we are basically done. We thank you very much for your attention, and we thank you also to the colleagues from St. Petersburg for giving us a stage today, and are open for questions both online and offline, and afterwards feel free to send us an email. Thank you.
Yes, sure, Ivan and the team, thank you so much for such detailed presentation. We have a question from the audience, from Pavel Volkov, but unfortunately we don't have enough time to discuss it right now because we are really out of time. So may I just suggest that you meet after the session in the networking and just discuss what you have in common. And thank you, Ivan, so much for remembering us and our self-sovereign identity. It was very nice to hear. So I would suggest moving on to the networking. Have a good day.